While they're still hollering at the same volume, the farther back they get, the quieter the sound is perceived by the observer. And we look at the inverse square law for this. So the inverse square law looks like this. The power is consistent the whole time. So each of them were screaming at the same with the same amount of power. But the farther out they get, the more that sound spreads out. And it doesn't just spread out to the observer's ears, but it spreads out to anywhere else that's in that same distance. And so it could go up, it could go back, it could go to the side, wherever, and it can spread out to that three-dimensional sphere that is at that radius r. And so when we're talking about the intensity here, we're looking at the power over the surface area of that imaginary sphere. So it's P over 4 pi r squared. In this diagram, one orange square is 1 meter squared. And so when you go out to the different distances, that 1 meter squared becomes a smaller part of that total area. And so the sound is spreading out to all of that. And so when it's at that 1 meter squared, remember we're talking about watts per meter squared. So when there's more meters squared for it to spread out to, the intensity is lowering at the same time. In this next demonstration, my younger son is 1 meter away and my older son is 6 meters away. We know the older son is louder, but the younger son is closer. And so you'll hear him louder in this one than in the other ones because my older son, who's louder, is much farther away. So there's much less intensity at the spot where I'm standing. So let's take a look at this equation. We have intensity as power over area, and the power is going to be measured in watts, and the area is in meters squared, giving us watts per meter squared, and it shows the two ways that might be written. So what we're talking about is the power that's coming from the source, and in this case we're using sound. It can also work for light. You have the power from the source over the area that it is spread out. And so it doesn't matter at that radius, whether it's up or down or to the side or any angle, if you take that radius, you can create a three-dimensional sphere at which that sound can reach. And anywhere on that sphere, your intensity is going to be the same. And so we use this equation with the amount of power that we have and then the radius of where it could spread out, even though we're making that collection at a single point.